Okay, last one. So, just pull up the question so we can see it. Ah, yes. Now we have a question with it. Okay, cool. I know what I'm doing. All right, so basically the last version here that we're thinking about, I'm just trying to remember what color I haven't used yet. Go with the purple, I guess. All right. The last version is this one here, which is the one using concentration. With this concentration one, again, they can work in both directions. They might go concentration to energy or energy to concentration. So just keep that in mind, that basically what I've talked about in these two questions can apply to this one. The only thing that's different is that instead of using this equation with the molecular mass, you're using this equation. So this one here can go from conc, or volume of solution, to energy, and vice versa. I'm only going to do one example for you because I figured you guys will probably be okay to figure it out once I show you how to use it. It's the same, like I said, idea. All right, so here is our question. I might just pause. Actually, no, I'll pause and copy that down. All right, cool. I'm just going to open up this question so that way we can read the full version instead of just my draw to down one. So in this one here, we've been once again given the equation and we've been given the enthalpy value. This one you guys actually have done in the lab. You put magnesium metal into hydrochloric acid and you've produced the hydrogen bubbles, and you guys would have done this with the pop test. All right. This question here is slightly different because they're asking you to calculate the volume of hydrochloric acid, which is this guy over here, when 50 kilojoules of energy is released. They've given us our enthalpy here. The other thing they need to do for us is that since they're asking about what volume of hydrochloric acid that we need, they need to tell us the concentration of that hydrochloric acid. Because depending on that concentration of hydrochloric acid, you might need more or less volume of it. You guys understand that from titration. So these are our steps for this example with concentration. And again, it could work in multiple different directions. We could be asking questions that are going from volume to energy, from energy to volume. So it goes in both directions. It's basically going to be very similar to what you've seen in the last two problems. The only difference is that I'm using the concentration equation instead. All right. So since in this case we are starting with energy and we're going to volume, we're using the second one that we second version that we've talked about. So we're basically using this energy to grams one that we just saw, but instead of going from energy to grams, we're actually going to do energy to volume. So the setup is going to be similar to what we saw in that previous question with step number one, being I need to figure out how many kilojoules per mole do I get for 1 mole of the hydrochloric acid. So again, remember that this equation here is referring to 1 mole of this overall reaction, but we are going to be having to change the ratios because we are talking about specifically the hydrochloric acid. So for every 2 moles of hydrochloric acid, what's going to happen is we are releasing negative 462 kilojoules. Now I want things, like I said, again, in 1 mole per liter. So if I want things in 1 mole per liter, kilograms per mole, brain's really not working. So we're going from here to here. So what that means is I need to divide it by 2. So if I do 462 divided by 2, I get negative 231 kilojoules. So what that tells me is that it is negative 231 kilojoules per mole when it comes to 1 mole of hydrochloric acid. So that's my first step. Second step then is exactly the same as the previous one. We know how much energy is released. We know then how many moles we're going to get. So I would do 50, and I'm dividing it by, so negative 50 because that's the energy released, We can go negative 3, 2, 1, 3. Sorry, 2, 3, 1. You don't need those negative signs. It's just to kind of show that you know what you're doing. All right. Oh, that's kilojoules. So my kilojoules cancel out. I have per mole. So I can then get my moles. So 50 divided by 231 equals 0.21645, and there's lots of numbers after it, moles. So that's how many moles I need. Now I'm going to be figuring out volume. So concentration is equal to moles divided by the volume. I have been given concentration up here, which is 2 moles. And I'm basically solving the equation for for V. Again, lots of different ways you can do it. First way you can do it is by rearranging the equation. So if I wanted to rearrange it, multiply each side by V, that cancels out. Divide each side by C, cancels out. So V equals N divided by C. If that isn't your cup of tea, again, they're only going to give you the equation in one format, so you're going to have to rearrange it. The other option is that you can draw the triangle. As much as I hate the triangle, I know some of you guys really like the triangle. Or the other thing you can do is you can plug in the numbers and just manipulate it with the numbers itself. It really doesn't matter so long as you get it. So I'll do it both ways. So V equals the 0.21645 moles divided by the concentration, which I have up here, 2 moles per liter. That's really good because then I can see the moles are canceling out with the moles, and we have per liter, so that makes it a liter. The other thing you can do is you can keep the equation as it's originally set up. And basically just rearrange it so that way you're just doing the same thing. You get V equals that divided by that. So it doesn't matter. All right, so we divide that by 2. And so for my volume then, I would need 0.10822, and there's lots of numbers, liters. We want 3 sig figs, 1, 2, 3. That's a 2, we round down. So volume is going to be 0.108 liters. You can convert it into milliliters, but you don't need to. And that's the answer for that one there. So that's everything.